Welcome to today's lesson on sample space with probability. What we're going to do today is learn what sample space is all about and how we can list it with one or more events. And then we will also see how many combinations there are of several events happening. So let's get started. First, if we want to list the sample space of just one event occurring. So let's go ahead and list the sample space for each of these different experiments, and you will copy this onto your notes. All right, first we have a spinner, and sample space is a list of all the possible outcomes, and we use these brackets and commas in between each one since we are making a list. So the first outcome that could occur would be a 1. I could spin the spinner and get a 1. Then we put a comma. I could also get a 2, comma, a 3, comma, a 4, comma, or a 5. So this is a list of all the possible outcomes, or we call it the sample space of spinning this spinner. There are 5 different possible outcomes, as you can see inside of our bracket. Let's take a look at drawing a card. What are all the possible outcomes of me drawing a card from this hand? Well, first I can see that there's an ace of diamonds. We'll just put ace. Then I can see that there's a 10. I can see that there's a queen, a king, and a jack. So these are all the possible outcomes. And once again, we have 5 possible outcomes. So if I were asked to list the sample space of this experiment, I would put the brackets ace, comma 10, comma queen, comma king, and comma jack. That is our sample space. Let's take a look at the next spinner. For the next 3, I would like you to go ahead and pause the video. I would like you to try. List the sample space below each of the following pictures. The spinner right here, this spinner, and our coin. Go ahead and pause and then restart to check your answers. All right, let's take a look at this first spinner. One possible outcome is I could get red. So I'll just put R for red. You do not always have to list the whole word. Another possibility is that I would spin green. The last possibility is that I would spin a blue. So here our sample space shows us that we have 3 possible outcomes. In this spinner, now even though there's hearts on different ones, if I was just looking at the shapes and not worrying about the colors, then I would list my sample space as a heart and a star, and that would be it. Now, if I wanted to be more specific, I could say a heart, that's blue, comma, a star, that's red, comma, a heart, that's green, a heart, that's purple, or a star, that's orange. So that would be a lot more specific with this. So there would be my sample space, and then there would be 1, 2, 3, 4, 5 possible outcomes for this spinner. Last but not least, we have just a regular coin, and our 2 possibilities is I could flip a heads or I could flip tails. So there are 2 possible outcomes for flipping a coin. Please fix any problems that you did not get correct. All right, now let's take a look if we have 2 events. Here's our experiment. We are going to draw a card, and then we are going to spin this spinner. So there's a few ways that we can go about this. Let's start by just listing the sample space. So one outcome is that I have an ace and a green. That's the outcome that is shown right now. So when it says what is the outcome that you see right now, let's go ahead and put ace and green. Again, just an abbreviation is fine. So that'll be our first possibility right here, that I draw an ace and I get green on the spinner. Well, then we could put a comma. What if I drew a 10 and got a green? So that would be another possibility. Then I could draw a queen and get a green, a king and get a green, or a jack and get a green. Okay, so once I've listed all the possibilities with green, all the card combinations with green. Now I would list all the card combinations with blue and then all the combinations with red. Go ahead and do that, and I will do that, and then you can unpause to see if you did it correctly. All right, so I finished my list. I did every card with green, every card with red, and every card with blue. So if I could now answer this question, how many combinations of cards, card and spinner, are possible? So I can see there were 1, 2, 3, 4, 5 with the green, then 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 possible combinations. Or I noticed that when I spun a green, there were 5 combinations. And then there were 5 combinations with red and with blue. So I could also figure that there are 5 cards times 3 different colors. So 3 colors. With each color, you can see there are 5 possibilities. So another way to figure out how many combinations is we simply multiply. How many combinations or how many different outcomes on the spinner, how many different outcomes of the cards. If I multiply it together, notice I get the same answer as I did when I made the list. There's one more way I'd like to show you, and that's doing a tree diagram. So this is me right here, and I'm going to choose a card and spin a spinner. Let's start with the cards. There are 5 different cards I could draw. So 1, 2, 3, 4, and 5. And I'm just going to put the first letter, ace, 10, queen, king, and jack. Now once I've picked my card, there are 3 different colors. So if I picked an ace, I could get red, green, or blue on my spinner. Sorry, it's a little crowded here. If I get a 10, I could also get red, green, or blue. If I drew a queen, I could spin red, green, or blue. A king, red, green, or blue. And a jack, red, green, or blue. If I count how many ends to this tree there are, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, I still get that there are 15 combinations. So those are 3 different strategies that you can use to find the number of combinations when 2 or more events occur. All right, let's try the sock problem. Here's my issue. I have 3 pairs of socks. They are blue, white, and red. But I have a new puppy named Copper, and he took all the pairs apart, he mixed them up, and now they're in my drawer, all mixed around. But I got up in the morning and I didn't want to turn the light on, and I pulled 2 socks out of my drawer in the dark to wear to school. So here's the first question. How many combinations of colors could I wear to school? So I'm picking one for my right foot, one for my left. What are the different possible combinations of socks could I be wearing? List them and remember that this is called the sample space. So let's try our 3 strategies over here. So here's me drawing my socks out of the drawer. And the first sock I draw could be blue, could be white, or it could be red. So that's the first possibility. Now I'm going to draw another sock, sock number 2. Let's say I draw the blue sock first. Now for my second sock, I could draw another blue, a white, or a red. So let's follow this trail. Blue, blue. Here's the outcome of blue, blue. Blue, white. That's my second option. That's blue, white here. Blue, red. We have it listed here. Now let's go back to sock 1. Let's say I drew a white first. My second sock could still be blue, white, or red. So now we could have white and then a blue, a white and a white, a white and a red. All right, the third way, let's start again with sock number 1. I could draw red first, and then for the second sock, I could get a blue, a white, or another red. So we have red, blue listed here, red, white listed here, or red, red listed here. So we used a tree diagram. We also use that tree diagram to make our sample space list. So let's list that here. So let's use this list right here. Our first outcome was blue and blue, then blue and white, blue and red. And go ahead and pause the video and finish that list. All right, so yours should look like mine. Please fix it if you need to. So you can see that a tree diagram can also help us form that list or that sample space. So if I count my sample space, we can see how many different combinations there were. I could have a blue and a blue and a white red, white blue, etc. So 1, 2, 3, 4, 5, 6, 7, 8, 9 different combinations. All right, so how many of those combinations mean I get to wear matching socks to school? Let's look at how many from our list have two of the same color. So we have blue and blue, white and white, or red and red. So it looks like I have three combinations where I would wear matching socks to school. And let's list them. Blue, blue, white, white, or red, red. So we could say, what's the probability that I will draw a matching pair of socks? Well, three of them are matching out of 9 combinations total. So I have a 3 in 9 chance of drawing matching pairs, or we could simplify that to a 1 in 3 chance. So good luck to me as I try to match my socks on my way to school. All right, we will do more of this in class. Good luck.